Bismillahirrahmanirrahim. This video is going to talk about volume by washer method. There are two cases in solving volume by washer method. Case 1 is cross-section perpendicular to the x-axis of revolution. That means x-axis. Look at our region here. We have a region between two curves fx and gx. And then our cross-section here, fx minus gx. Then our region here, we want to revolve at x-axis. Revolve about 360 degrees. So if we want to find the volume of the revolution, we will use washer method when our cross-section is perpendicular to the axis of revolution. And also here, we have two formula of volume. Where the first one, we look at our axis of revolution here is below of our region. So we will use formula volume V equal to pi integration fx minus k. Fx is our function fx minus k. K is our axis of revolution. So fx minus k square minus gx is our function gx minus k is axis of revolution. So gx minus k square integrate respect to x. And AB is our value between our region A to B. The second formula is when our axis of revolution above of region. So we will use formula volume V equal to pi k minus gx. K is axis of revolution. Gx, our function here, square minus k axis of revolution minus fx, our function fx here, square. Integrate respect to x. Case 2 is cross-section perpendicular to the x-axis of revolution by mean y-axis. If we have the region between two curves fy and gy, and the cross-section is fy minus gy, and then this region we will revolve at k, revolve about 360 degrees. If we want to find the volume of revolution, we will use washer method, where our cross-section is perpendicular to the axis of revolution. Also here we have two formula of volume. The first one is if our axis of revolution at the left side of the region, we will use formula V equal to pi fy minus k. Fy is our function here, minus k. K is axis of revolution, square, minus gy, our function gy, minus k is axis of revolution square, dy. Integration respect to y, and limit CD is value between our region here is C to D. The second formula is if our axis of revolution at the right side of the region. So we will use formula V equal to pi k minus gy. K is our axis of revolution minus gy, our function gy here, square, minus k axis of revolution minus fy, our function fy here, square, dy. Integration respect to y. Look at this example. Find the volume of the solid obtained by rotating the shaded region about the line y equal to -1. So our shaded region here, we want to revolve at y equal to -1, revolve at 360 degrees. So we want to find the volume of the revolution. And look here, our cross-section is perpendicular to the axis of revolution. So we will use Gaussian method. Look here, our axis of revolution is below of our shaded region. Remember our formula? We will use v equal to pi integration of fx minus k square minus gx minus k square dx. Integration respect to x, so function in terms of x. Equal to pi integration, our region here between 0 to 1. So integration 0 to 1. Fx is our function on the top, y equal to x, so x minus k is our axis of revolution is -1. So k is equal to -1 square minus our function gx is function on x square minus k is our axis of revolution is -1 square dx. Then simplify our function. Here we write as x plus 1 square minus x square plus 1 square dx. And then expand x plus 1 square, we will get x square plus 2x plus 1 minus expand x square plus 1 square, we will get x to the power of 4 plus 2x square plus 1 dx. Then simplify our function. We will get negative x square minus x to the power of 4 plus 2x dx. Then we can integrate our function. Negative integrate x square, we will get x cubed over 3 minus integrate x to the power of 4 is x5 over 5 plus 2 integrate x is x square over 2. And we can cancel 2, 0 to 1. Then substitute x equal to 1. So we have -1 over 3 minus 1 over 5 plus 1 minus substitute x equal to 0, we get 0. Calculate this one, we will get 7 over 15 pi unit cube. Next example, find the volume of the solid obtained by rotating the shaded region about the line x equal to -1. So we have our shaded region here between two curves x square and x. We want to revolve this region at x equal to -1. So we want to find the volume of the revolution. So look here, our cross section is perpendicular to the axis of revolution. So we will use formula of Gaussian method. So first we look at our axis of revolution here is at the left side of our region. So we will use formula v equal to pi c to d fy minus k square minus gy minus k square dy. So integration respect to y, so our function must be in terms of y, where we write our function y equal to x as x equal to y, and this function x equal to square root y. So our formula v is equal to integration of c to d. We look our region from 0 to 1 at y-axis, and then fy is the function at the right side, that is square root y. square root y minus k. K is our axis of revolution is -1. So k is -1 square minus gy. Gy is the function at the left side is x equal to y. So y minus k is our axis of revolution -1 square dy. Then simplify our function. So now we have square root y plus 1 square minus y plus 1 square dy. Then expand square root y plus 1, we will get y plus 2 square root y plus 1 minus expand y plus 1, we will get y square plus 2y plus 1 dy. Then simplify our function. We will get negative y minus y square plus 2 square root y dy. So our integration equal to negative y minus y square plus 2. We need to change type of square root y to y the power of 1 over 2 because we want to integrate that function. Now we will integrate our function equal to pi. Integrate negative y, we will get negative y square over 2 minus integrate y square is y power 3 over 3 plus 2 integrate y the power of 1 over 2 is y the power of 3 over 2 over 3 over 2. Limit 0 to 1. Simplify 2y the power of 3 over 2 over 3 over 2. We get 4 over 3. Y the power of 3 over 2. 0 to 1. Then substitute y equal to 1. So we get negative 1 square over 2, 1 over 2. Negative. Substitute y equal to 1. 1 over 3. Plus substitute y equal to 1. 4 over 3. And then minus substitute y equal to 0. We will get 0. Calculate this one. We will get 1 over 2 pi. Unit the power of 3.